Okay, let's take a look at page 72, question number 2. Explain how to transform the graph of y equals root x to obtain the graph of each of the function. State the domain and range in each case. Okay, well, to transform the graph, remember our root equation is y equals a by b root x minus h plus k. So if we start out the first example, for y equals 7 root x minus 9, I have a equals 7, b equals 1, h equals 9, and k equals 0. So the graph of y equals root x is vertically stretched by a factor of 7 and translated 9 units to the right. So the domain is if x minus 9 is greater than or equal to 0, or is x such that x is greater than or equal to 9. X is an element of all real numbers. And the range, because k is 0, is y such that y is greater than or equal to 0. Y is an element of all real numbers. And that's for A. If we look at B, we have A is equal to 1, B equals negative 1, H equals 0, and K equals 8. Now the graph of root x is reflected in the y-axis and translated 8 units up. So to get the restriction for our domain, this one I'm just mentioning it because we have negative x is greater than or equal to 0. Okay. So essentially, we're dividing by negative 1. And when we divide by a negative, this inequality switches. So x is less than or equal to 0. So for our domain, it is x such that x is less than or equal to 0. I better do that. It switches. X is an element of all real numbers. And the range is y such that y is greater than or equal to 8. Y is an element of all real numbers. If we take a look at C, our domain and range, our domain will be x is greater than or equal to 0, and our range is y is less than or equal to 0. I'll just put it right here on the side. Is x such that x is greater than or equal to 0, and the range is y such that y is less than or equal to 0. Because it's stretched, it's reflected in the x-axis and stretched horizontally. Okay, so that's the reason why the range is in that solution. Okay, Let's take a look at 3. Match each function with its graph. Okay, so for y equals root x minus 2, what we have is a equals 1, b equals 1, h equals 0, and k equals negative 2. So the graph of y equals root x is translated 2 units down. So the graph 2 units down will be b. So therefore, I will put here graph b. Okay, let's take a look at b. Y equals root negative x plus 2. Well, let's just analyze this. A equals 1, b equals negative 1, h equals 0, and k equals 2. Okay, so the graph of y equals root x is reflected in the y-axis and translated 2 units up. So therefore, if we take a look, it will be graph A. Let's take a look at the next one. Y equals negative root x plus 2. Well, in this example, A equals negative 1, B equals 1, H equals negative 2, and K equals 0. So the graph of y equals root x is reflected in the x-axis and translated 2 units to the left. So that would be graph D. Last example, y equals negative root negative x minus 2. So A will be equal to negative 1, B equals negative 1, H equals 2, and K equals 0. So the graph of y equals root x is reflected in the x-axis and in the y-axis and translated 2 units to the right. So therefore, it will be graph C.